guys, today we're going to look at target 10C, which is properties of trig functions. So before we've seen a little bit of sine and cosine and the different angles. So now would be if we actually graph an equation such as y equals sine of x. Okay. One thing that we'll notice about these trig functions is that they're periodic functions. It's a function that repeats forever. And it's periodic because as I change my angle, let's say I'm at 0, I'm at 90, I'm at 180, I'm at 270, I'm at 360, right? Really what we're doing is we're going around in a circle. And at 360, the circle restarts. So this function is really just repeating because you're just continuously walking around in the same circle. You're never changing from that. So the period of the function is the length from one point to the matching point. So for example, if I was talking about degrees, at 0, when I'm all the way back at 360, right, I'm back at the beginning of my circle. So that would be the 1 period. We're going to be looking at radians, so it'll be a little bit different, but the 1 period is when you get back to the repeating point. And then we have what we call an amplitude, and the amplitude of a periodic function is the height from the center to the peak. So this is an example of a periodic function here. It's repeating. The period, they went from one peak to the next peak, right? So that distance, how far that is from one to the next, horizontally, is what we call the period. And you can see the amplitude here, right? It starts at the center and go up. I can either start at the center and go up or start at the center and go down. It'll be equal, okay? There. So then we have two functions we are going to be looking at. We are going to be looking at the sine function and the cosine function. So our sine function is graphed here. One thing to note about the sine function is the sine function starts at the 0, 0. Okay? So it's on the origin. If I have something like y equals a sine of x, I don't like how that's written. I'm going to rewrite it twice. Y equals, I'm going to rewrite that. We're going to be looking at y equals a sine of bx. Okay? So I can have a number on the front, and I can have a number being multiplied by x. My amplitude for this function is the absolute value of a. So whatever number is out in front, okay, but it's always positive. Okay, your amplitude is just a distance, so it's going to be positive. The period of a function is going to be 2 pi divided by b. Okay, and that 2 pi really comes from, if you think about a circle in radians, right, like I was saying, at 360 degrees it restarts. Well, in radians, our period will restart at 2 pi. So that's where the 2 pi comes from, and then it just gets changed by whatever number is in front of x, 2 pi over b. And then our cycle, for a sine function, it starts at 0. That's what you notice here. And then we say it goes to its max, or it will go up. It'll go back to 0, min, and at 0 it restarts. So at 0, max, at 0, a max, 0, a min, 0, a max. I could keep going on forever in that, following that pattern. Okay. For cosine, I'm going to do the same thing. I'm going to rewrite this. Y equals a cosine of bx. Pretty much everything's exactly the same. Our amplitude is the absolute value of a. Our period is 2 pi over b. The only thing you'll notice is our starting point changes. If I look at the y-axis, now I am starting at a max. This one goes max 0, min 0. Alright, so you can see, like, if I start this max 0, min 0, max 0, min 0, max, right? It just repeats that pattern forever. That's what makes it periodic. Let's look at some examples we would see with this. So for the following functions, determine the amplitude, period, and the number of cycles that are on the given interval. We're going to say, for the given interval, our given interval is going to be from -2 pi to 3 pi. amplitude, when we're looking at a graph, is just how far up it goes, right? So my max point is at 2. You can tell my center point's at 0. So my amplitude here is 2. My period. Well, I want to see how long it takes me to get from back to the same point. So I have to go through the cycle. 0, max, 0, min, 0. Alright, so 0, max, 0, min, 0. So I started my cycle here, I end my cycle here, from 0 to 4 pi. So my period is 4 pi. Okay. And then my number of cycles. The easiest way to think about it is negative 2 pi to 2 pi is 4 pi long. So how many of the periods that I have found fits into that number of cycles? Well, how many times does 4 pi go into 4 pi? 4 pi divided by 4 pi equals 1. Okay? Just like negative 2 to 2 is 4 units long, negative 2 pi to 2 pi is 4 pi equals 1. Alright, looking at our next example. Our amplitude, right? Well, if I think about how far up it goes up 4. So our amplitude is 4 units. Our period, well, this is a cosine function. I can tell this starts at a max point, right? The difference in the cycles. So I have to go max, 0, min, 0, max. That's right between these 2 points is how long the period is. So it looks like it goes from 0 to 2 pi. So my period is 2 pi units long. And then the number of cycles on negative 2 pi to 2 pi, well, if it's 4 pi, right, so negative 2 pi to 2 pi is 4 pi, and each period is 2 pi, that means there are 2 cycles. And that's it for those. Next, let's look at our table. Okay. So you might be given your information in a table. Our amplitude is pretty easy to find. You'll have zeros and then max and min, right? And max is 5, my min is negative 5, right? A high point and a low point. So therefore my amplitude is 5, right? It's going up 5 every time, it's going down 5 every time. Period. Again, I want to start at 0. So this starts at a max. So this would be cosine. Max, 0, min, 0, max. 0 to 2 pi. Alright. So my period is 2 pi units long. And finally the number of cycles. So to better this, I will keep going the workflow, right? We have 4 pi units in our interval. Each period is taking 2 pi. That means you can get through it once. So we have 2 cycles there. Easy enough. C, what is our amplitude, right? Well, there's a whole bunch of 3. So our amplitude is 3. Our period, that's what's next. Right, okay, again, start at 0. 0 max. 0 min 0. Our period is pi units long. So then our number of cycles. Well, again, there's 4 pi units in our interval, divided by there's pi units in each period. That means I'm going to get through it 4 times. And the number of cycles is 4. Okay, the last way you might see these is in an equation. It's what we started with. So our amplitude, remember, amplitude comes from the number in front. So our amplitude equals 2. Our period equals 2 pi divided by the number with f. So 2 pi divided by 4. I do want to reduce my fraction. 2/4 is the same as just 1/2. So my period is pi over 2. And how many cycles can I get through, right? So I want to do 4 pi divided by pi over 2. Remember, a lot of times if you use mixed fractions, you can do 4 pi times, just flip your second fraction, 2 over pi. Pi cancel out, 4 times 2 is 8. Or, thinking about it the same way, how many times does 1/2 fit into 4? Right, 8 times. Last example, our amplitude is 1/2. Our period is 2 pi over 3. Sorry, 2 pi divided by this number, right, 3. That does not reduce, so we're just going to keep it as 2 pi over 3. And our number of cycles is, right, 4 pi divided by 2 pi over 3. Again, I'm going to flip that fraction, 4 pi times 3 over 2 pi. 4 times 3 divided by 2, you should get 6. There are 6 cycles. Okay. And that is it for the properties of periodic functions. I'll see you guys tomorrow. Have a great day.